For about 40 minutes on April 6th, 4 astronauts were completely cut off from Earth. No signal, no contact, just the crew of Artemis 2, a small capsule, and the moon filling every window. And in that silence, they started seeing things that did not look like anything in the textbooks. Fine strands of light curling around the edge of the sun, flashes popping on the lunar surface, a glow that made the moon look less like a dead rock and more like something still running. The question is not whether these things happened. They did. The question is what they mean. The flyby plan turns into an observation trap. The goal of the flyby was not to land. It was to loop around the moon, test the Orion spacecraft in deep space, and bring the crew home safely. A proving run before future missions attempt an actual landing. But built into that loop was something the engineers could not avoid: the far side of the moon. When Orion swung behind the moon, radio waves could not get through. The moon itself blocked the signal. About 40 minutes of blackout followed, one of the longest communications gaps in human spaceflight history. Mission Control knew it was coming. The crew knew it was coming. That part was not a surprise. What made it unusual was everything the crew did during those 40 minutes. NASA's science team had prepared an observing program specifically for this window. The cabin lights inside Orion were turned down to cut window glare, the same way you would dim your phone screen to see outside at night. The crew had a list. They had objectives. They were not just floating there waiting for the signal to come back. They were working, watching, and pointing cameras at things most humans have not had reason to look at closely since the Apollo era. The stakes here are worth pausing on. The last time a crewed spacecraft gave humans this kind of eclipse view from near the moon was during Apollo. That program ended in 1972. More than 50 years passed before anyone got another shot at this geometry, this distance, this angle. Dr. Kelsey Young, lead for NASA's Science Mission Directorate, noted before the flyby that the eclipse would look completely different from anything we see on Earth, because from Orion's position, the moon appears much larger than the sun, which changes the whole character of what is visible around the edges. While Orion was behind the moon, it also reached its maximum distance from Earth for the mission. NASA described that figure as suspected to be about 252,756 miles. That phrasing matters. They were not even certain of the exact number yet, which tells you how far outside normal operating territory this spacecraft went. The crew broke the distance record set by Apollo 13 in 1970, the farthest any humans had traveled from Earth until that afternoon. And from that position, they started building a list of things that did not have clean answers. 3 categories kept coming up as the flyby data started filtering back. First, the sun side. During the eclipse, the crew reported seeing structures in the solar corona they described as baby hairs, fine streamers wrapping around the moon's silhouette. Second, the moon side. The crew saw 4 separate impact flashes on the lunar surface, and they made a concerted effort during Earthrise to look for dust lofted above the moon's edge, a phenomenon scientists have not yet fully explained. Third, the wider sky. Viewers saw a steadily blinking dot that confused live audiences until NASA's science team confirmed its identity. Each of those buckets tells a different part of the same story. Some of what the crew saw has a clean explanation. Some of it sits in a gray zone, where the science is real, but the implications remain open. And one moment in particular made even a veteran astronaut reach for a Las Vegas analogy because ordinary words did not seem to capture what he was seeing. As the sun slipped behind the moon and the eclipse began, Orion stopped being a spacecraft on a flyby. For nearly an hour, it became the best-positioned observatory humans have ever had for watching the sun's outer atmosphere do things we still do not fully understand. The eclipse, baby hair corona, and the sci-fi moon glow on Earth, totality during a solar eclipse, lasts a few minutes. You get maybe 2 or 3 if you are standing in the right place at the right time. The Artemis II crew got nearly an hour. That is not a minor difference in duration. It is a different category of experience entirely, because the longer you watch, the more your eyes adjust, and the more the faint features begin to appear. What they saw around the moon's edge during that hour was the solar corona, the sun's outer atmosphere, which normally gets drowned out by the blinding brightness of the solar disk itself. Block the disk, and suddenly you can see structure, streamers, shapes, material that has been sitting there all along, invisible because of the glare. The crew called them baby hairs. That is not a scientific term. It is what Victor Glover reached for when he was trying to describe fine strands of solar material curling out from around the moon's silhouette. Streamers in the corona are real, documented structures, plasma-shaped and held in place by the sun's magnetic field. Solar physicists track them, model them, and use them to study how energy moves through the sun's atmosphere. So the phenomenon itself is not a mystery. What catches you off guard is the scale. From Orion's position, the moon appeared much larger than it does from Earth, which meant the corona was framed differently than any ground-based eclipse photo you have seen. The geometry changed everything. The contrast between the moon's hard, dark edge and those faint, bright filaments was sharper than usual, and the eye can resolve detail in that kind of contrast that cameras often compress or lose. Glover specifically noted how hard it was to capture what he was seeing on camera. The image flattens it. The live view does not. His comparison was blunt. If you have ever seen the spotlight beam off the top of the Luxor Casino in Las Vegas, this looks like what that wants to be when it grows up. He was reaching for the biggest, brightest beam of light he could pull from memory and saying the corona made that look small. That is not hyperbole for the cameras. That is someone genuinely running out of reference points. A solar physicist would tell you that the streamers themselves are well understood in principle. But well understood in principle does not mean every observation from every geometry is already mapped. The viewing angle from near lunar orbit, sustained for almost an hour, with human eyes adapted to the darkness, is not a configuration scientists have had before in the modern era. What the crew saw may hold detail that ground observatories, which are fighting atmosphere and shorter windows, simply cannot match. Then the eclipse shifted what was already a strange scene into something Glover called SCI-Fi. Earthshine is Earth's reflected sunlight bouncing off the lunar surface and back into space. From the ground, you can sometimes see it as a faint glow on the dark part of a crescent moon. From Orion, pressed up close and with the sun fully blocked, the effect was something else. Glover said you could see a majority of the moon's surface in that darkness, not a sliver. Most of it dimly lit, floating in front of what he described as not the blackness, but the gray that blends and drifts into the blackness. He called it a visual illusion, and technically, he's right. Earth is bouncing sunlight onto the near side of the moon, filling in the shadows, flattening craters, softening edges in a way that makes the surface look wrong to anyone who's used to seeing the moon in direct sunlight. But the illusion part is just the perceptual effect. The light is real. The surface detail it's revealing is real. And here's the thing that stays open. If Earthshine during a near-total eclipse can illuminate that much of the lunar surface from that distance, then the same lighting geometry should be capable of revealing things that usually stay invisible. Faint dust above the surface, subtle glints, brief changes at the limb that ground telescopes aren't positioned to catch. The crew wasn't just watching the sun, the moon was answering back. The moon answers back, impact flashes, and the dust question. While the crew was watching the sun's atmosphere do things that broke their reference points, the moon itself was doing something harder to explain away. 4 times during the flyby window, the crew witnessed impact flashes, distinct bursts of light on the lunar surface, brief and bright, as space rocks slammed into the moon at full speed. All 4 strikes landed on the near side, the face of the moon that always points toward Earth, near or south of the lunar equator. 2 separate meteors were also spotted during the same window, burning visible against the dark sky from Orion's vantage. To understand why that's worth stopping on, you need to know what impact flashes actually are. The moon has no atmosphere. There's nothing to slow a rock down, nothing to burn it up in the way Earth's air does. A meteoroid that would leave a faint streak across a night sky here hits the moon's surface at full velocity and dumps all of that kinetic energy into a single, brief flash of light. It's over in a fraction of a second. The crater stays. The flash is gone before most cameras can lock onto it. Catching one during a ground-based observation takes patience, dark conditions, and often dedicated monitoring equipment. Catching 4 in a single flyby window, with human eyes adapted to near-total darkness during an eclipse, is a different situation. The science explanation holds. These are meteoroid impacts. The moon gets hit constantly, and the near side, simply because it's the face we point instruments at, is where observers have always had the best chance of catching these events. The eclipse conditions made them easier to spot, not more likely to happen. Dark surface, high contrast, adapted eyes, you are going to see things you would normally miss. But the question that sits just underneath that clean answer is harder to dismiss. If a 4-person crew in a capsule, watching through spacecraft windows for a single flyby window, can catch 4 distinct impact events in roughly an hour, what does our usual count of lunar impacts actually represent? Ground-based monitoring programs catch impacts when conditions cooperate. They are not watching continuously, and they are not watching from a vantage point that eliminates atmospheric interference. The near-moon environment may be significantly more active than most people assume, not because of anything strange, but simply because we have never had this kind of front-row seat before. That question connects directly to what the crew was doing during Earthrise. As Earth appeared to rise above the moon's horizon, from Orion's perspective, the crew specifically looked for dust floating above the moon's edge. That was not a casual observation. It was part of the planned science program. The reason it was planned is that lunar dust lofted above the surface is a phenomenon scientists have not fully explained yet. The leading candidate is electrostatic charging. On the lunar surface, solar radiation and the solar wind strip electrons from dust particles, giving them a charge that can push them upward. Micrometeoroids, the same constant rain of small rocks that causes those impact flashes, also act like a sandblaster, kicking surface material up and out. During eclipse conditions, with the sun's light geometry changing and Earthshine providing faint but real illumination from a different angle, the conditions for spotting lofted dust were about as good as they are likely to get. What the crew found during that Earthrise window has not been reported with a clean conclusion. They looked. The science question stays open, but the fact that the observing program included it at all tells you that dust behavior above the lunar limb is still an active problem, not a solved one. It connects the impact flashes and the dust into one continuous system. The moon's surface is getting hit, material is getting lofted, and lighting geometry during an eclipse might be the only time humans can actually see it happening with their own eyes. Live viewers watching Orion saw a steadily blinking dot in the upper left of the frame. It was bright enough to stand out against the dark background, and steady enough to feel deliberate. NASA's science team confirmed shortly after that the dot was Venus, one of the brightest objects in the night sky, visible from Orion because the eclipse stripped away competing light and let it show up clearly on camera. Venus matters not because it is mysterious, but because it shows what space observation can reveal. A well-known planet, one of the brightest things in the sky, looked strange enough to need an explanation. Brightness, window optics, camera behavior, and the absence of familiar reference points can conspire to make normal things look anomalous. That context does not cancel the impact flashes, the corona streamers, or the dust questions. Those are separate, confirmed observations. But it does help calibrate how to hold all of it together. The far side glimpse adds one more layer. Orion's closest approach brought the crew within about 4,067 miles of the moon, and at that distance, roughly 21% of the lunar far side was visible and illuminated. The crew reported seeing features of the far side that have never before been seen by human eyes. Not photographed from orbit, but seen directly through windows in real time. The honest version of what all of this adds up to is straightforward. The moon is not dead scenery. It is a surface getting struck, a landscape that lofts material, an environment where lighting geometry changes what is visible, and a place where the gap between what we think we understand and what we have actually observed up close is larger than most people realize. The mental model most people carry was built from ground-based data and short Apollo windows. Orion just spent an hour breaking parts of it. The clearest views happened when Earth could not hear them. The blackout did not hide anything. It just gave 4 people an uninterrupted hour to watch, and the moon did not sit still for it. Corona streamers broke every reference point. 4 impacts appeared on a surface we called dead, and Earthshine revealed a face the cameras could not hold. That is not nothing. If you want more deep space stories told this way, subscribe and send this to someone who still thinks the moon is just scenery.